The world has changed. You don't need data to know that the world has changed. Some changes are for the better, some not so much. But it's definitely a new world out there. Less of the same old, more once in a century. Less certainty, more unpredictability. Less margin for error, more urgency to get it right. There's so much riding on our shoulders. It's not like the fate of the world rests in our hands. Actually, it kind of is. The answers are out there. All you need to do is start your journey. No one knows what's coming next, or where all this is going. But if anyone can predict the future, it's us. Wherever you look, the challenges are daunting. From forecasting the next hurricane, to forecasting this year's hottest fashion trend. From solving supply chain disruptions, to solving what to watch tonight. From building sustainable solutions to building his college fund. They all have one thing in common: you. Because data and AI are essential to solving all of them. And that puts you at the center. But you can't do it alone. It takes a team. It takes a community. We don't all come from the same place, but we're all heading in the same direction, side by side, heading toward the same destination, Lakehouse. In hindsight, the future was always clear. This is where we were always heading. To a place that's open to everyone. Built for the way you work. So we can not only predict the future, but shape it. Together.
Please welcome Ali Ghodsi, co-founder and CEO, Databricks.
Hey everyone, welcome. Super excited to be here. This is awesome, finally in person. Last time was 3 years ago. We could do this in person. I also want to thank everyone that's watching online. So we have about 5,000 people here at Moscone Center. It's fully sold out. And we also have about 60,000 people virtually checking in. In the last 2 years, this community of open source projects that we see have been growing out of bounds. And it's really awesome to see. And I'm really, really looking forward to an awesome event this week. We actually have over 160 countries represented in this event. So we have people from all over the world calling in, watching these videos. We have developers, data scientists, analytics engineers, software engineers, thought leaders, industry leaders, and it's a true community event where we get together, can learn from each other, and move our industry forward. Before I move on with our program, I want to first take a minute to thank our sponsors. Without these companies that sponsored this event would have not been possible, so let's give them a round of applause. And I also want to really congratulate everyone who took training here. So we actually trained 30,000 people here at this event. So 30,000 people. And 120 of them are actually certified. So it's a really special thing to be certified. So this way, we're growing the community and getting more and more people to learn these technologies, growing this open source community. So we're super excited about this. But what I'm here to talk about today is how data analytics and AI is disrupting whole industries. So the companies that we see on this slide, the FANGs, they all use data, analytics, and AI in a really, really strategic way. They used it in every use case, in every department, and they were that way able to completely change the world. Right? If you think about it, a company like Google wouldn't even be around today if it wasn't for AI. We'd be using AltaVista. Okay? Twitter wouldn't even work if it wasn't for how it picks those tweets and shows you what you want to see. So these companies did it. But nowadays, we also have more and more larger enterprises that are also able to do the same thing. So one of my favorite examples is AT&T. AT&T takes data that's previously used to sit in a data warehouse. This is subscriber data. And they combine it and join it with real-time event data that's coming in. And this event data is someone wants to change their phone number or they signed up for something. And they can join these in a lakehouse, and they can, in real time, be able to provide 182 million subscribers with fraud alerts. So in real time, you'll know that, OK, someone's trying to hack your account. And this would have not been possible if it wasn't for data, analytics, and AI. So how are these companies doing it? What is it they sort of cracked the code on? And we really, really think that this data AI maturity curve explains what they were able to do. So on the x-axis here, you see how mature some companies or organizations' data and AI is. On the y-axis, you see how much value they're getting out of it. So how competitive is it for them? And on the left-hand side, it starts with just getting the raw data, cleaning it, starting to ask questions about it, making reports, doing some queries. But then as you move to the right-hand side, that's when you're starting to use predictive technologies. That's when you start using that crystal ball, and you're asking questions about the future. What's my revenue going to be next quarter? Or which of my customers are going to churn? Or which product do I think that you want? That's when you really, really get competitive advantage out of data and AI. And that's when it becomes really disruptive. It's on the far right there. And today, unfortunately, most organizations aren't on the right-hand side of this curve. They're somewhere on that spectrum, and they're struggling. And the reason they're struggling is that there's this big technology divide in this data and AI maturity curve. So on the left-hand side, as you get started, you store your data, you start asking some basic questions. The simplest way to do that, and the best stack in the past, has been to put your data in a data warehouse, and then plug in a BI tool like Tableau or Power BI, and then you get your dashboards. So that was the easiest way. But then as you want to move to the right-hand side, and you want to ask about the future, then suddenly that stack doesn't work. So you have to completely redo it, use a different technology stack. You store your data in a data lake, and then you start using AI technologies on top of it, and you hire different type of people. So you hire data scientists for that. On the left-hand side, you hire analytics engineers or analytics folks. And there's this big divide between the two. And this divide is pretty bad because what it actually looks like in most organizations that I see is that all of their data is first landing in what we call a data lake. So on the right-hand side, you see all data comes in. This is all the raw data. It could be logs. It could be things that their software is producing, images, audio, text. But then to do anything on the left-hand side, they have to copy it over to the data warehouse, and then they can plug in their BI tool. Okay? But if they want to do any real-time streaming or machine learning, then they have to access it directly in the data lake in the raw file format. And this is really problematic, and this is really slowing down organizations. The reason for that is you have now 2 copies of your data. It's duplicative and siloed. If new data arrives in the data lake, it's not going to be reflected in the warehouse. If you update the data in the warehouse, it's not going to be reflected in the lake. So this whole industry of data ops has been created, and you have to hire all these folks, and all they're trying to do is reconcile all these different copies of the data lying around. Okay? So that's problem number 1. Problem number 2 is securing the data, making sure that it's private is really, really hard because you now have these 2 incompatible modes. On the one hand side, you have these files. On the other side, you have these tables and columns. And if you configure one wrong, you might suddenly have prevented someone from getting access to data that they should have access to. Or even worse, someone might have gotten access to some data they should not have access to. So this is a big problem, this big divide on the security side. And then, of course, the use cases. You can't really run the dashboards on the lake. It won't perform well. and you can't really use the data science and real-time applications on the warehouse, you pull it out, you copy it out. So that's what's happening today. But what if we could unify these two, and we could all just have one repository of all of our data? So we store all our data in the lake. But what if we crack the code and figure out how to make it really reliable and really fast? Okay? So that's the first layer. And what if we could actually, on top of that, also figure out one security model and one governance approach for all of that data? Okay? Whether it's files, or whether it's tables, or whether it's machine learning models, or dashboards, or whatever it is. And what if we could just do all these use cases all in one place on top of this data? So whether you're doing real-time streaming, or machine learning, or analytics, or BI, you should just do it in this one stack. And this is what we call the Lakehouse paradigm. So that's what we're going to be talking about a lot this week. In the Lakehouse, you have this one unified, simple platform for all of these use cases. And at Databricks, the way we accomplish this is with the following technology stack. We have Delta Lake, which is really core technology to making this happen. So Delta Lake is really the secret sauce that enables you to take all that data, make it reliable and fast. So we're going to hear a lot about that from the creator of Delta, Michael Armbrust, here today. And then on top of that, Unity Catalog is the technology we use to really make sure that we can govern and secure all data assets in your Lakehouse. So there are going to be lots of talks on that as well. And then, of course, on top of it, we have all the technologies. So our data warehouse, Databricks SQL, our workflows, our streaming engine, structured streaming, and machine learning platforms end-to-end. So all of this can be done in this tech stack on top of it. And that's what we call the Databricks Lakehouse platform. And this week, we have a lot of exciting announcements on this Lakehouse. So on the governance layer, we have lots of talks. So it's going to be really, really exciting to hear what's happening on the Unity Catalog side. On the data warehousing side, I'm going to share with you some benchmark results that we haven't actually published before. So that'll be exciting. And we'll also tell you how we implemented it. So there's going to be a talk on exactly how we made it really fast and how we made it work. On the data engineering side, we're going to hear from Michael Armbrust on Delta. It's going to be a really exciting announcement there. And on streaming, we're going to tell you about a new effort that we've started that just targets streaming workloads. And then, of course, on data science and machine learning, we're going to hear about how we can actually integrate all of this in the platform. So it's going to be really exciting. So why do people want this Lakehouse? So we spent a lot of time actually asking customers, what makes you excited about this Lakehouse approach? And 3 themes came up over and over again. And the themes were, number 1, it's simpler. I don't need to have lots of different data repositories, move things around, making sure that they're consistent. And I don't need to have lots of infighting in my organization between different data scientists and DBAs and others that can't agree on the technology stack. This just makes it simpler. So that's number 1. Number 2, 80% of our customers actually say that they're on more than one cloud. So this number keeps increasing every year. So they don't want to do this again and again on different clouds. It's hard enough as it is. Building it up on just one cloud, making it work on another cloud with different set of technologies, they don't want that. So they're saying, we want one multi-cloud approach that just works across all of these. And the third thing that we found that actually really matters to most organizations is that they want it to be open. They want to have open source, open standards, and that's really important to them because they don't want to get locked into one vendor. They've done that before. Most CIOs that I talk to, they say, we don't want to be in this game of, after 10 years, trying to get rid of legacy software. We don't want to be locked in. And this openness is really important when it comes to the ecosystem. So we're going to have lots of talks here this week by other vendors and by other open source projects. And they can really integrate with this Lakehouse approach that we have because all the core elements are open source. So you can actually get a Fivetran and do ingestion and connect it with Databricks. Or you can use a dbt and build your data pipelines. Or you can use a Immuta or Prevacera or Colibra for your governance. You can use Tableau, Power BI, Looker for your dashboarding. And for machine learning, we have lots of partners, and on data science as well. And then, of course, we have all the SIs that we work with that can actually help build solutions for these organizations that need help. So this open ecosystem is really, really important. It helps people get educated, get classes, books, MOOCs. So that's what's creating this movement. And actually, we've now started focusing on verticals. So we're focusing on different industries and focusing on the use cases in each of these industries. So we launched a Lakehouse for healthcare and life science. We launched a Lakehouse for retail, media entertainment, and fintech. And each of these Lakehouses, they come with templates of how you can actually already solve the problem if you don't know. So if you haven't done it before, here's a template for how you do risk analysis in finance. and you can get started with that immediately. And we found that this really helped many organizations. So this is great. The Lakehouse is awesome. And we're super excited to see that there's lots of other people who've taken notice of this as well. So in the industry, lots of folks are talking about the Lakehouse. So here's Microsoft talking about using a Lakehouse or building a Lakehouse on top of Microsoft Azure. This is Google talking about open Lakehouses on Google Cloud. And you can see they actually have an offering recently that helps you build these Lakehouses. And AWS have been talking about this for a while as well. They just spell Lakehouse with a space in the middle. We also have Oracle now talking about it. And these vendors are even around still. And even classic data warehouses are saying that they're Lakehouse. OK? So everybody has a Lakehouse. If you actually Google data lakehouse, you'll see lots of ads bought by lots of vendors. What is a data lakehouse? Everyone wants to tell you what the Lakehouse is. But if there are so many of them, which is actually awesome, I actually think this is how people will want to build data and AI. This is how you move to the right-hand side of that curve. I really think the future of data is AI, and the way you accomplish it is with the Lakehouse. But when there's so many vendors saying, hey, we have this too, it becomes a little bit confusing. So how do they stack up? How do these compare? So I'm going to share with you benchmark results on how they actually compare. So what I'm going to show you, we haven't published before. It's called the Lakehouse benchmark. And in the Lakehouse benchmark, we did the following thing. We took all these different vendors that claim they have a Lakehouse, and we used them as a Lakehouse. What does that mean? It means that we stored the data on a data lake in an open source format, Parquet, and then we used a data warehousing benchmark on that data. Okay? So just to be clear, we did not use them as a data warehouse. We did not ingest the data into a data warehouse. We stored it on the lake itself and used them as a Lakehouse. And here's what you'll see in the results. So on the left-hand side, you have the Databricks warehouse engine as part of the Lakehouse. And then you have Cloud Data Warehouse 1, Cloud Data Warehouse 2, and Cloud Data Warehouse 3. And the fourth one is a multi-cloud data warehouse. Okay? And what you can see is that we could do this for $8, whereas if you look at the vendor 4, it's 30 times more expensive. So there's a 30x price differential to try to do this on a Lakehouse with these other approaches. Okay? And you might say, hey, how did you do this benchmark? It's TPCDS, 3 terabytes. How did you tell me exactly? What did you do? Maybe we're wrong. Maybe we got the numbers wrong. Maybe this 800-pound gorilla is actually 750 pounds, okay, or 600 pounds. It's still a huge gorilla, okay, in the room. It's still a giant difference between these, okay? We didn't get it 30x wrong, I hope. So that means this is actually going to matter, and we're seeing more and more organizations saying, hey, if I can do this 30x cheaper, and I can actually do machine learning, I can do real-time streaming, and I'm not getting locked in, maybe I should actually move to this. And we're seeing actually the movement. We're seeing it in the numbers. People that are migrating over and using this instead. So this really matters to people, and especially if there's now we're seeing there's more and more pressure. There's cost pressure on CIOs. They get less budget and they have to do more with that. Then they think, yeah, maybe I'll pick this. OK, so that's the Lakehouse. But you might be thinking, OK, but this is kind of cheating. This is using them in an unintended way. Okay? What if you actually use them the way they were optimized? So we did that as well. Again, we used Cloud Data Warehouse 4, the blue one there. And here's when you use them apples to apples. So here's what we're doing. We're loading the data in. So we're also taking into account that you have to load the data in to the system. And then we also now are actually computing how much does it cost when they optimize the tables. Okay? Because that actually turns out to be a significant cost. So that's called auto-clustering. And then on top of it, we run all the 99 TPCDS queries. And you can see here, still a huge difference. Okay? So this is apples to apples. That's a data warehouse stored as a data warehouse. On the left-hand side is the Lakehouse that Databricks provides. And you can see big difference between the two approaches, especially if you want to use the enterprise tier that most companies want to use. So there's a big difference. And you can see this here. And actually, if you're using a Lakehouse, it's even better than this, because the load portion if you already have your data on a lake, you don't need to do the load portion. So the dark green portion goes away, but you still have to pay for that dark blue, assuming you already have your data in a lake. OK, so that's benchmarks. You could say, hey, they're synthetic. Who cares about TPCDS? All that matters are customers and what people are doing with this. Tell us about use cases. Anyone can cook up some numbers. So I want to just show you 3 examples of 3 customers that are actually doing this at scale. So first one is a global media company. You all know about it. This company, they were able to actually take a data warehouse that they used to have, where they had subscriber data, and then they would get these real-time events that were coming in from people watching their streaming videos online. Okay, so it's a very popular streaming video provider. And they joined these, and using this, they were able to build personalized models. And with that, they were able to actually cut down their data warehousing cost by $30 million. And they actually created $40 million of accelerated revenue because they were able to keep people online because they improved the video quality with this. So that's one vendor using a Lakehouse. The other one is a Fortune 10 retailer. So it's a huge retailer. We all know about it. They were able to combine traditional supply chain data that they had in the warehouse with real-time IoT sensor data that was coming in. And that way, they were able to actually reduce food spoilage. And they claim that they can actually save $100 million worth of food spoilage with this approach. And they have 10 times faster time to insight. And the final one is Atlassian. It's one of my favorite companies. They've spoken here multiple times on stage. And what they said is they got rid of their data warehouses completely, and they've adopted this Lakehouse approach. They actually use it for all kinds of things. They've actually democratized data inside of their organization. One of my favorite use cases is if you go into Jira and you type anything, it will actually predict what you're about to write, and that's all created in a Lakehouse. And that actually helped them lower their costs of warehousing by 60%, and they were able to actually deliver much faster insights to the organization. So this is awesome. That's why we're so excited about this. We want to democratize this. We want to bring this technology, this revolution to everyone. And our approach is to do it with the Lakehouse. We have a really exciting show for you this week. We have a fantastic lineup. We will have Spark, Delta Lake, MLflow projects, and announcements around each of these projects. We're going to hear about a new streaming project that we're launching. And you're going to hear about trends like MDS, data mesh in the Lakehouse. We have data-centric AI from Andrew Ng, Peter Norvig, and Hilary Mason. And we also have how can we use AI in education to change people's lives. And we're going to have lots and lots of innovations that our customers from Databricks are going to talk about this week. So it's going to be super excited. So let's get started. All right. So that brings us to our first speaker this week. I'm super excited to welcome Reynold to stage. Reynold is Chief Architect at Databricks. He's also a co-founder. He's #1 committer on Apache Spark project. But before I get him on stage, I want to share with you a funny story. So he actually was a PhD student at UC Berkeley when I met him the first time. And believe it or not, his PhD thesis was about how can you use SQL to ask questions from human beings. So using SQL to ask questions from humans. You can actually you can Google it. It's called CrowdDB. So without further ado, I'm super excited to welcome Reynold to stage. Reynold, come on.
Thank you, Ali. Good morning. It's so nice to see all of you here in person, especially in this very room about a year ago where I got my first COVID-19 vaccine shot. Good memories. So today, we have 2 exciting announcements representing actually some of the largest changes to Spark's project since the project's inception. But before I dive into those, I want to share with you some community updates. The world has changed forever in the last 2 years. In the middle of the pandemic, if you're like me, you picked up cooking, baking, and playing with big data. And that's why it's no surprise that Apache Spark's growth has been continuing going up, and it's now being downloaded more than 45 million times a month just on Maven and PyPy alone. That's 45 million times a month. This is actually the 13th year of the Apache Spark's project history, and it's really astonishing how much the project's continuous success is getting. So in 2020, about 2 years ago, the HackerRank developer survey actually indicated for people with Apache Spark skills, your wages have gone up almost by 30% between 2019 and 2020. And this survey was echoed by another survey from Stack Overflow just last week, the 2022 Stack Overflow Developer Survey, that Spark was the top-paying technology at the top. So congratulations to all of you, especially the ones that received the certificate earlier today. The survey really indicates the demand in the labor market for Spark skills. And now you know what to talk to your manager about in your next one-on-one. Right? And I also know it's kind of annoying to see Ruby on Rails just right up there above Spark. But it's not just stats that's growing. At ACM Sigma conference, also just happened 2 weeks ago in Philadelphia, Spark was awarded the ACM Sigma Systems Award. Now, this is a very big deal because Sigma is the most prestigious database community. It is actually where relational databases were born. The ACM Sigma System Award recognizes systems with significant impact on the theory and practice of large-scale data systems. And this is really a testament to Spark's adoption as well as its influence on the generation of systems to come. But Spark's not just resting on its past glories. There's so many changes that's happening across the board, going from Python to SQL to performance. Usually, a decade into the project, you kind of see the project start stagnating and not really changing that much. But there's so much change happening right now. I won't have time to go into any of the details. There's some examples on the screen here. I encourage you to check out the deep dive talk tomorrow at 2 p.m. to learn more about them. So for all of you that's here, you know that Spark's often associated with big compute, large clusters, thousands of machines, big applications, right? But the reality is data applications don't just live in data centers anymore. They can be everywhere. They can be interactive environments that cover notebooks, IDEs. They can happen in web applications. They can happen even in edge devices. Raspberry Pis, HomePods, your iPhones probably have a lot of applications that can benefit from the power of data. But the reality is you don't see Spark ubiquitous in all these environments. Why is that the case? So if you zoom in, you realize Spark has a monolithic driver. This monolithic driver runs both the user's applications as well as all of the Spark code. And this includes the analyzer, the optimizer, and the full-fledged distributed execution engine. This coupling of the monoliths of the user's application and the Spark code actually makes it very difficult to embed Spark in any of the sort of more remote environments. As a matter of fact, the opposite is happening. You have to embed the applications in Spark. So for people to work, some people work around this by figuring out, hey, why don't I just send SQL strings, for example, over from my application to some sort of gateway that happens in Spark. But SQL doesn't actually capture the full expressiveness of Spark. It is just a much more limited subset. It's great, but it doesn't run, for example, your machine learning applications. Some other projects come up with their custom protocol to send code over, like Jupyter Notebooks with Jupyter Notebook kernels. But that's very, very difficult to debug. And for a lot of programming languages that simply don't have JVM interops, you can barely even get it working. Now, let's say you actually figure it all out and actually got some custom protocol going and it's really working. You run into a whole suite of multi-tenancy operational issues. And the fundamental issue here is the lack of isolation. All right? One application that's consuming too much memory and malbehaving might create a out of memory exception. But it doesn't just the application itself. It every other application in the same driver. A lot of other problems with dependency conflicts. It's also very, very difficult to upgrade your application or upgrade Spark because you have to upgrade all the application and Spark at the same time. Right? Same thing with debuggability because you might not actually have network connectivity onto the Spark clusters for security reasons. And observability as well. So with that, I'm super excited today to announce Spark Connect, which in my mind is the largest change to the project since the project's inception. Spark Connect enables applications anywhere to leverage the power of Spark, the full power of Spark. So what is Spark Connect? The idea is very simple. We want to create a decoupled architecture and a stable client-server protocol so we can embed a thin client in any applications. And this client API is designed to be thin, so you can really embed anywhere you want, even computation devices, devices with very, very little computation power. And it's designed in a way to be language agnostic, so you can actually use it in any programming language you want. Let's take a look at how this works. So we're creating, again, just a protocol between the client and the server. And this protocol is language agnostic, it's quite simple, and it's very stable. And the prototype actually uses gRPC and uses protobuf. All the client needs to do is you have your client's data frame API in any language you want, if the native language. And then it generates unresolved logical query plans based on proto, and sends the unresolved query plan over to the server, which is the Spark code, using gRPC. All of this happening in a language agnostic way. And the server can execute that query plan using the standard query optimization execution pipeline, and then sends the result back. Now again, using gRPC and Arrow in a language agnostic way back to the client, and the client can interpret the result and do whatever it wants with it. This is very similar to think about SQL, sending SQL strings over, but using JDBC, using ODBC, or using any of the client drivers you might be using for database drivers. But there's so much more than just sending SQL, because you have the full power of the data frame API in Spark. So with this protocol, and with thin clients we can create, now we can actually embed Spark in all of these devices, including the ones with very limited computation power. And such devices can actually drive and orchestrate all of the programs, and actually offload the heavy lifting execution over to the cloud in the backend. So this architectural change also mitigates a lot of operational issues we just talked about. For example, applications that use too much memory actually the driver itself. Not only its own client, it has no impact on any other applications. Dependency conflicts are now isolated to the client itself. And it's much easier to upgrade, because you can either upgrade the application one at a time or upgrade the server. As a matter of fact, if we design it right, you could even upgrade the server without changing the application at all to gain the benefit of all the latest performance and security patches. It's very easy to debug, because you just use whatever native programming language toolchain to attach to the application. You can do all your step-by-step debugging. Same thing with observability. So rather than me talking more about it, I would like to invite Martin Grun, the project lead from Databricks responsible for this contribution, onto stage to show you a demo. Welcome, Martin.
Thanks, Reynold. Thank you. All right, so we talked a lot about how can we actually demo Spark Connect, and all I got was a SQL query and an iPad, so let's see what we can do. All right, so I open this app here. I have a pre-configured Spark shell, and I will now create a data frame based on a SQL query that I've previously copied in my clipboard, and typing on an iPad is hard, so please bear with me a little bit. Okay. All right, so here we have the SQL query that I got. I don't really know what it's doing, so the next thing I'm going to do is actually printing the metadata of the projected columns to get an idea what's in there. All right, so what happens now is that Spark Connect goes to the Spark cluster, resolves the plan, and gives me back the projected columns. All right, so I've seen Spark version 3.3. I'll create a new data frame in a whole PySpark notion that I know and love, select the date column, df.date. Then I will select the version 3.3. And lastly, the total number of downloads. Oops, and all right, total. And to make it more interesting, I will then sort the result by date in a descending order and only show the last 10 or the top 10 results. All right, cool. So, but what happens behind the scenes? So every Spark Connect plan has a built-in logical unresolved plan that Reynold already talked about, and I'm going to show you how this looks like. So you can always look at the composition of your Spark query at any point in time. And as you can see here, there's a SQL query, a projection, and a limit. All right, so now let's just collect the data. And then we get the result back as a pandas data frame. Since it's a pandas data frame, I can use pandas directly on my iPad again to create a new column that then calculates the number of total downloads from Spark version 3.3 over the total number of downloads to get the ratio. Okay, so divided by S of total. Okay, and now I will just print the result. OK, so again, it goes back to the server. And what we see now is that over just 7 days of releasing Spark 3.3, it went from 0% of the downloads to about 35% of the total PyPy downloads. And what you see here is that I used an iPad, Python on an iPad, I used Spark, I used Python, I used Pandas all in one to show how easy it becomes to build modern data application. And with that, I'm giving back to Reynold. Thanks.
Thank you, Martin. I think it was actually his own personal iPad. Thank you for donating that. So, in case you haven't realized and noticed, what Martin is doing was actually, he was orchestrating all of this computation on his iPad, which offloads most of the heavy lifting part of downloading, crunching through like actually billions of records onto the cloud, all right? So 7 years ago, when we first started Databricks, we thought it would be so out of the realm of possibilities to run Spark on mobile that I personally wrote this blog post for April Fool's Day called Re-architecting Spark for Mobile Platforms. It was before Spark 2.0 even came out. We're at Spark 3.3 now. Wall Street Journal actually fell for it and called us and tried to verify the authenticity of this. But we were wrong. We didn't know this would be possible, and with Spark Connect, this could become actually a reality. So Spark Connect was officially voted as a SPIP just a couple of weeks ago, or Spark Project Improvement Proposal. The community is now working hard to actually bring it forward, and very likely you'll see experimental support for it in the next few releases, starting with Python, but obviously eventually rolling out to all the other programming languages as well. So the second thing I want to talk to you about today is about streaming. We have seen an explosive growth of streaming applications also, just in the past few years. And right now, just on Databricks alone, we have more than 1,200 customers building streaming applications and running streaming applications every day. And this has led to over 150% year-over-year growth of streaming jobs. So today, I want to tell you more about what we're doing with Spark Structured Streaming. And with that, I would actually like to invite Karthik onto stage. And Karthik is a well-known figure in the streaming community. He's a co-creator of Pulsar, Storm, and among other things. He was also the former CEO of Streamlio, which is a streaming company that's responsible behind the project Pulsar. And he happened to be the most technical CEO I know, so on the planet. So welcome, Karthik.
Thanks for the intro, Reynolds. I think most technical title CEO goes to Ali. He gives a lot of great feedback on the design documents, deeper feedbacks. So I started Databricks last year, and one of the things that I wanted to find out was why Spark streaming is popular. So we talked to a lot of customers and users and found out there are a lot of reasons they use Spark streaming. And here are the top 5. First is unification, because we have batch APIs and streaming APIs are the same. So if you're already using Spark streaming, all you have to do is just change the configuration a little bit, and you can turn it into a streaming job. So the second, robust fault tolerance and recovery. So Spark automatically checkpoints at every stage of the processing and stores the state. And then whenever a failure occurs, it recovers from the previous state. So whenever failure occurs, it automatically recovers from the previous state. The failure recovery also is very fast in the sense like only the failed tasks are recovered. So it is opposed to the streaming systems like Flink, which allows you to restart the entire pipeline. So the third one is performance. So the structured streaming provides very high throughput with the seconds of latency at a lower cost, using full advantage of the performance optimization of the Spark SQL engine. One of the deployment we have done around 14 million events that corresponds to 1.2 trillion events per day for the most challenging workloads. And the fourth, flexible operations, ability to do arbitrary logic and operations on the output of a streaming query using for each batch operation. It allows you to do a lot of what you call absurd and output to multiple sinks, etc. Then finally, we have the stateful streaming, which is inbuilt into Spark streaming itself. So it supports a lot of inbuilt stateful aggregations and joins and other operators with watermarks for bounded states. In addition, you can do arbitrary stateful stream processing as well, where you can write your own stateful operators in Java and Scala. So as Spark streaming grow, a lot of new emerging applications, developers started using it to develop these new applications. Let us look at a few of them. So first, proactive maintenance in oil drilling, where you continuously monitor the data and so that the drill bits do not strike a hard surface. So you have to do proactively monitor this data. Second one is elevated dispatch. So where you continuously monitor the elevated data for emergency purposes and dispatch and alert the dispatchers for any situations. Third, tracing microservices. Stitch the request and response from microservices that serve a web request for tracing and troubleshooting purposes. These applications expose some of the shortcomings of structured streaming. So if we address these shortcomings, we can even see a much more skyrocketed growth. So what are we doing about it? So before that, I wanted to find out what are the requirements that we need to, these emerging applications are driving. First is consistent sub-second latency. Second one is ease of expressing processing logic for complex use cases. Then the third, integration into very different cloud sources and sinks so that Spark's structured streaming can operate with multiple sources and sinks in the new era. So structured streaming needs to evolve to satisfy these new requirements. So what are we doing about it? So I'm very excited to announce Project Lightspeed that takes Spark's structured streaming to the next generation. So what is Project Lightspeed is all about? There are 4 pillars in Project Lightspeed. First, predictable low latency. We are targeting reduction in tail latency up to 2x. Second pillar is enhanced functionality, ability to capture advanced capability, introduce advanced capabilities to capture the processing logic very easily using new operators and APIs. Third, operations and troubleshooting, simplify deployment operations, troubleshooting, and so that you can get to the issues quickly and get the pipeline back up and running. And finally, kind of improve the connectors and ecosystem where you can connect to different systems in the cloud and write data into the sinks in the cloud, and also improve features like authentication and authorizations. So first, the next few slides, I will go through some of the highlights of Project Lightspeed. So the first one is about how we are going to achieve predictable low latency. So SSS, Spark structured streaming, has several bookkeepings. So one is at the start of the micro batch, another is at the end of the micro batch. So the start of the micro batch essentially plans what records constitute into the micro batch, and that is forced into external storage. Second, the micro batch is started and executed. And the third, the batch is marked as done. So that is the second bookkeeping at the end of the micro batch. So these bookkeepings has to be stored in storage before the start of the micro batch and end of the micro batch. So that is executed in sequence. So that causes a lot of latency. So when we did an implementation and measured it, we clocked around 440 milliseconds. So now, when continuous streaming is occurring, in fact, like where micro batches are executed one after the other, so you don't need all these bookkeepings. You can simplify the bookkeeping further. So we can eliminate the mark batch done because the offset ranges itself serves as a marker. So now the offset ranges do not have to be forced into disk. Instead, it can be returned while the micro batch is executing or overlap with the micro batch execution. So this, when we did a POC implementation, it gave around 120 milliseconds. That is around close to 4x improvement or 73% improvement in latency in stateless pipelines. So second improvement in predictable low latency is improved state checkpointing. So currently, when the microbatch is executing, after the execution of the microbatch, the state is propagated to the external storage synchronous fashion before the next microbatch is started. So in the asynchronous checkpointing that we have implemented, so we overlap the microbatch execution with the propagation of the state asynchronously. This achieved another 20 to 30% in stateful pipelines, which is another major improvement. So in the next slide, let's look at some of the advanced functionality that we are doing, where we are going to use for Python as a first-class citizen. Spark's structured streaming pipelines can be programmed using multiple languages. One is Java, Scala, and Python, and SQL. Python is a popular choice by a lot of developers, and Python provides several APIs for DDL operations and DML operations like filtering, joins, aggregation, grouping, and windowing. But there is a gap, which is what we are going to address, and that's what for arbitrary stateful processing. So there are two APIs that map group with state and flat map group with state, which allows the user to write their own stateful operators like exponential weighted average for the financial community and other operations. The challenge with this API is this is arbitrary Python code that needs to be executed in a JVM system, or it can be executed in an out-of-process system and bring the data back in. So there are challenges in implementing this as well. So the next, let's talk about how to improve debuggability. So this Spark streaming pipelines are very brittle even in any streaming systems. So there can be several reasons. One is surge in data, and resources are not adequately provisioned, and bug in users' code. So whole idea is to pinpoint the problem quickly and get the pipeline back up, especially most of the streaming pipelines are real time. So Spark structured streaming provides a lot of metrics and logs and at every microbatch level. But what it doesn't provide is a timeline view of metrics for the operators. And the operators could be at different levels. One is the operator that is expressed at logical level and how it's optimized at the physical level, et cetera, right? So we need to provide a timeline view of the metrics for operators at the physical level. Then the group operators by executors and incorporate source and sink metrics so you have one single pane of glass. So and to look at how the source is pumping the metrics and how Spark is processing the metrics, processing the records, then followed by how sinks are getting the data. So finally, connectors and ecosystem. So we are going to add more connectors for Amazon DynamoDB and Google Cloud PubSub, and also sync for Amazon Kinesis to send some alerts and everything for operational pipelines. And we are going to improve existing connectors. First of all, performance improvement for Delta-like connectors so that we can write data faster into Delta. Second one is like incorporate the AWS IAM authentication for managed Kafka services from AWS. Then we are going to add a EFO enhancement for Amazon Kinesis, which allows you to do higher bandwidth. So and many more features. In case if you are interested more in Lightspeed, a blog will go out live at 9:30. Please look it up, and we have a list of all the features that we are going to roll out in Lightspeed. And if you are interested in a community collaboration with us, there are a lot of JIRAs that we have opened on the open source, and we are very welcome to work with the community. And if you are interested, come and talk to us, or come and talk to me. And that's all I had. Thank you.
Awesome. That's super exciting. We actually saw 2.5x growth in revenue for our streaming workloads last year. So I think streaming is finally happening. Every year we're waiting for that year where streaming workloads take off, and I think last year was it. And I think it's because people are moving to the right of this data AI maturity curve, and they're having more and more AI use cases that just need to be real time, like real-time fraud detection. Okay, so I am really, really excited to introduce the next speaker. He really doesn't need an introduction, but Michael Armbrust is creator of Spark SQL. He's also creator of structured streaming in Spark, and he's also creator of Delta. And before I welcome him to stage, I want to tell you a story about him in Berkeley. So at UC Berkeley, he was always the student that was first with everything. So he was the first student to have an iPhone. So everybody would gather around his desk and say, oh, wow, you know. And he was also the first one to start using Git, so version control at UC Berkeley. So can you imagine, if he didn't exist, we wouldn't have version control in Spark today. So without further ado, welcome Michael Armbrust.
Thank you so much, Ali. I am really excited to be here in person and with all of you virtually to talk about Delta Lake. In this talk, I'm going to talk about three things. I'm going to explain what Delta Lake is and why it's the foundation of the Lakehouse. I'm going to tell a story about Delta Lake's history, which is actually deeply entwined with this conference we're all at today. And then finally, I have a really exciting announcement about Delta's future. So first of all, what is Delta and why is everyone talking about it? Well, as Ali said this morning, there's always been this big divide between data lakes and data warehouses. Data warehouses were the traditional technology. They were really easy to use, they were really fast, but they were expensive and not very scalable. Data lakes were the young upstart. They came in, they let you store tons of data, but they were kind of slow and clunky and difficult to configure. And Delta really was created to unify these two worlds. It brings ACID transactions to the data lake, and it brings speed and indexing, and it doesn't sacrifice its scalability or its elasticity, and it's what enables the Lakehouse. When Delta first started, it was mostly a Spark technology, but that couldn't be further from the truth today. We have connectors for everything from old school technologies like Hive to fancy new technologies like dbt, which you'll hear about in just a little bit. This year has been no different. We've added a ton of different connectors. We've added support for Flink, Trino, and Presto, and we're working on support for Pulsar and Google's BigQuery as well. As the ecosystem has expanded, so has our user base. So I think a year and a half ago, when we released Delta 1.0, we were only getting about 500,000 downloads per month. And today, it's at over 7 million downloads per month, which is pretty cool. And the other thing that's really been changing in the project is the health of the contributors. So this graph that I'm showing here is actually a metric by the Linux Foundation that looks at the health of contributions in any given open source project. It looks at how many unique people are fixing bugs and responding to pull requests and merging code. And so you can see really just how much momentum there is behind the project. And it's increased by over 600% in the last 3 years. But now I want to kind of rewind and take a trip down memory lane, talk about the history of Delta. So I'm going to go back to the year 2017, a much simpler time. I was working on structured streaming in Spark SQL, as Ali just said, and I was talking to a bunch of users at this conference about how they were processing tons of data from a variety of data sources. And they were doing it all in parallel on the cloud, and it was all great. And pretty much what every single one of them was doing was when they were done processing data, they were writing it out as Parquet files to S3. Parquet is this pretty cool open columnar format. It's part of a database, but there were still a bunch of problems. It turns out that a big collection of files is not a database. I was fielding bug reports from users constantly who were saying Spark is broken because what they were doing is they were basically corrupting their own tables because there were no transactions. When their jobs failed because a machine was lost, it didn't clean up after itself, multiple people would write to a table and corrupt it. There was no schema enforcement, so if you drop data with any schema into the folder, it would make it impossible to read. There was a bunch of added complexity of working with the cloud. The Hadoop file system just wasn't really built for it. I'm sure people in this room remember setting the direct output committer, and if you got it wrong, things would be broken. And even just working with large tables was slow. Just listing all the files could take up to an hour. And so it was here at what used to be known as the Spark Summit that I talked to a bunch of people and thought, there's got to be a better way. And I actually always take a couple of days off after Spark Summit to decompress. And I was so excited, I wrote a design doc during that vacation. And so in 2018, we came back on the stage and we announced Databricks Delta. It was one of the first fully transactional storage systems that preserved all of the best parts of the cloud. And even better, it was battle tested by hundreds of our users at massive scale. In fact, one of my friends, Dom, got up here and told us about his use case where he had been using Delta for the last year to process petabytes of data in real time with hundreds of analysts around the globe for a critical information security use case. If you haven't seen that video, I suggest you go to YouTube and check it out. But Delta was too good to keep just for Databricks. And so in 2019, we came back, and we announced the open source Delta Lake. And we didn't just open source the protocol, the description of how different people can connect and make transactions in the system. We actually also open sourced our battle-tested Spark reference implementation and put all of that code up on GitHub. But we weren't done with Delta. We were actually believed in this so much that Databricks started to commit its business to it. And so in addition to all the exciting things that were happening in Delta Lake, we were busy building features to make Delta even better. So we added this really cool command called optimize, which automatically takes all of your tiny files and compacts them into a larger one transactionally, so you can get dramatically better performance. We built this really cool command to go alongside of it called optimize zorder, which actually takes your data and maps it to a multi-dimensional space-filling curve so that you can filter efficiently on multiple dimensions. That works really well with this cool trick called data skipping based on statistics. It's basically like a coarse-grained index for the cloud. We added the ability to write to these tables from multiple clusters and a whole bunch of other things that I don't have time to talk about. But there's a problem here. All of this advanced technology, you could read and write Delta from anywhere, but all these advanced features were only available inside of Databricks. And that's why today I am really excited to announce Delta Lake 2.0. All of Delta is now open source. And so if you see this feature matrix, you can see we're already on our way. If you've been following the project closely, you might have seen something is up. We've been opening up tickets on GitHub, and we are rapidly open sourcing all of these different features and bringing them out for the community. And what we've seen is this is actually going to dramatically improve the performance of this open source project. So as you can see the baseline, this is Delta 1.0. With that optimize command, it improves performance a little bit. But when you add in zorder and data skipping, the performance gets really good, which is super exciting. This is the same TP-CDS query that we've been showing all day today. And the other really exciting thing is Delta is now one of the most featureful open source transactional storage systems in the world. We are the only one where you can run it directly against cloud storage systems like ADLS without any extra infrastructure. We're the only ones that have data sharing, and there's a whole bunch of other differentiated features. We also did a little bit of performance comparison across all of these different open source projects, and Delta is somewhere between 2 and 4 times faster than the next competitors. And we're not the only ones who have noticed this huge performance increase. So this is from some people over at DataBeans who are users of the open source project. And as you can see, they saw that we are dramatically faster, not only at loading data, but at processing data than Iceberg. But we're not done yet. There's actually some really cool technology waiting in the wings. I want to tell you just a quick preview of one of those things. So there's always been a problem with columnar formats like Parquet. The problem is due to the encoding, when you want to update even just a single value, you have to rewrite the entire file. This is called write amplification in databases because it takes a single tiny write and turns it into a big, massive copy of all of this unchanged data. And so we're very excited to add this new technology to the Delta protocol that allows you to delete a single row called deletion vectors. What this is going to let you do is it's going to let you mark that row as deleted so you can only write out the data that changed, which will dramatically speed up things like deletes, updates, and merges. And we've already gotten started on this effort. So as you can see, there's a couple of JIRAs, some of them already resolved, where we've been adding some of the groundwork to both Parquet and Apache Spark. Now, I would be remiss if I didn't recognize all of the great members of the community. So if we could give a round of applause for all these people who have made Delta what it is today. If you'd like to learn more, there's a ton of exciting things going on at this conference. Come and join us for our AMAs or our deep dives into various topics. If you want to get involved actually coding for the project, you can come to our meetup and actually talk to some committers and figure out some good projects to get started. If you're joining us virtually, you can still join the community. Check us out on GitHub or on Slack or on Twitter. And with that, I'll thank you very much. And now I'd like to introduce Dave Weinstein, the Vice President of Engineering at Adobe's Experience Platform. He's going to tell you about their journey into the Delta Lake. Thanks.
Good morning, everyone. I hope you're as excited as I am about the big announcement that we just heard from Michael. Let's take one more moment to applaud the entire Databricks company for taking this step to open source Delta Lake. Like Databricks, Adobe has a deep heritage of contribution to open source and open standards. From 3 weeks ago, when we were part of proposing the latest open cost project to the Cloud Native Computing Foundation, to 1992, when we invented PDF, the most widely used open document standard in the world, Adobe has always believed that open source and open standards are critical to delivering on our mission. At Adobe, our mission is to change the world through digital experiences. We unleash creativity for people by empowering creative people to connect in myriad ways. From the media we consume, to the ads we see, to the websites that we browse and shop on throughout the day. Chances are those experiences were touched by Adobe technology. Adobe gives everyone from emerging artists and influencers to the largest global brands what they need to design and deliver exceptional experiences. With Creative Cloud tools like Photoshop and Illustrator, we empower creative people everywhere to build beautiful and engaging visual experiences. With Document Cloud tools like PDF, Acrobat, and Sign, we accelerate document productivity, because sometimes you can't meet in person. And with the Adobe Experience Cloud, we power digital businesses, helping companies design and deliver experiences that drive profitability as well as loyalty. While most people know what Adobe does for powering document and creative productivity, far fewer are aware of the scale and impact that we have with the Experience Cloud on some of the biggest brands in the world. Our tools enable them to deliver exceptional experiences to their own customers, impacting all of us here today and everyone who's watching online. So what kind of scale are we talking about? Well, it's a lot. Every day, we collect in our real-time data collection systems over 150 billion discrete requests from our customers' website, mobile applications, and their real-time streaming systems. And we manage well over 32 billion distinct customer profiles across a broad swath of the largest brands in the world. And every day we compute over 24 trillion distinct segment realizations. Our system is continuously creating actionable audiences, allowing customers to personalize their customers' digital experiences. So how does Databricks help us to solve the big challenges of understanding and optimizing customer experience at this kind of scale? We'll focus on two big challenges. The first challenge is what I might call the merging of the hemispheres. Just as with people, many technical systems built to optimize customer experience suffer from what we would call a split brain personality disorder, where the left and the right brains struggle to effectively work together to deliver on the promise of digital customer experience. They're separated between the left brain, the place where analytical workloads are run, and their right brain, where real-time decisions about personalized experiences are made. The left brain in this equation is typically a customer data lake or data warehouse. It's where data is explored, where reports are generated, where new hypotheses are tested, and usually where AI/ML algorithms are deployed. The right brain is real-time experience delivery, which requires the use of low-latency access patterns, point reads, with latencies counted in milliseconds. Keeping these systems in sync is a big challenge. We see this same pattern in customer after customer. They struggle to keep their analytical and operational systems coordinated, and they suffer from this split brain personality disorder. So when we built the Adobe Experience Platform, we set out to solve this problem for our customers. At the center of the Adobe Experience Cloud, we've built a single common platform to integrate our applications and our customers' experience data. It's here at the foundational layer of our tech stack where we leverage Databricks and apply the Lakehouse concept and the Delta Lake table format. We provide easy ways to bring in data, whether it's streaming in real time or onboarding massive batches. And we've created a common paradigm for activating data seamlessly into whatever systems need it to deliver personalization at scale. The system brings the left and right brains together, allowing the analytical and operational brains to work as one unified whole. At the core is the architecture for which Databricks has coined the term Lakehouse. It has the scale and cost characteristics of a traditional data lake with the transactional and change data feed capabilities of a traditional data warehouse or database. We can leverage those change data feeds so that every record being inserted, updated, or deleted can be propagated continuously in real time into those real-time operational systems. This ensures that the operational brain can drive creative actions taken in the analytical hemisphere. The second challenge we faced was to address the needs of customers in the most challenging and highly regulated environments with respect to data governance and privacy. We heard from customers in healthcare, financial services, and telecoms that they need specialized capabilities in this area. To effectively satisfy the needs of enterprises for data governance at scale, it became clear we also needed to support ACID-style transactions at scale. This is where the capabilities of a lakehouse came into play. For access control, we worked with Databricks to add the ability to apply a filtering schema at query time so we can control which users and groups have access to the data. In the case of user activity audits, we can leverage the time travel and versioning capabilities in Delta Lake to support auditing of changes over time. And finally, data hygiene is where we saw some of the biggest benefits from Delta Lake. The change data feed allows us to manage record-level deletes and updates at scale and cost-effectively. Without Delta Lake in the past, we had one illustrative example where when we were leveraging Iceberg, we had to update 27 billion records in order to delete just 27 rows. Not only has this accelerated our ability to cost-effectively deliver those types of capabilities at scale, it's also accelerated the delivery. For the main architect who worked on the data lake portion of this data hygiene project, he estimated that we shaved 2 years of development time with our move from Iceberg to Delta Lake. So how did we take advantage of Lakehouse architectural patterns in order to support the new set of capabilities? We partnered very closely with Databricks every step of the way. First, in early 2021, we sat down with Databricks, shared our roadmap, and they shared their roadmap, and we aligned on what were the major challenges that we would have to overcome to be successful in this journey. Second, we had weekly meetings with Databricks, and we executed on 50 distinct POCs to verify support for our existing workloads and make sure that this transition would only bring positive benefits. We did find a few areas where there were feature gaps, and we partnered very closely with Databricks to close those feature gaps, and we're really grateful for the partnership that they brought to bear there. And then finally, just a month ago, at the end of May, we launched the first offering built on top of this new architecture, Healthcare Shield for our real-time customer data platform product. And I'd really like to thank not only Databricks, but the entire community around Spark and Delta Lake for the support that they've shown us in being able to achieve this. If you would like to learn more, thank you so much. If you'd like to learn more about Adobe Experience Cloud or Adobe Experience Platform, please visit the link above or scan the QR code and it'll take you there. And I'd just like to thank everybody here today for letting me share our Lakehouse story with you.
Right. Adobe Experience Cloud is really, really cool, actually. You guys should check it out. It's powering most websites, and now at the core it has a lakehouse. And we're super excited about the Delta 2.0 open sourcing announcement. So we're very excited to build a huge community around that project. But next, I want to talk about data governance, security, privacy, and we put the smartest person we had at Databricks to work on this. So I'm going to introduce Matei Zaharia, who of course needs no introduction in this audience. He created Apache Spark. But before he comes on, I want to tell you, back in Berkeley, 10 years ago, we were at the gym and we're trying to lift weights. And he's telling me, hey, I think we can actually do streaming inside Spark. And that's how Spark streaming came about, at the gym in Berkeley. So Matei, welcome to stage.
All right. Thanks, everyone. Really excited to be here. You can see Ali kept going to the gym after that, and I didn't. But you know, it was a lot of fun when we when we were going there. So I'm going to talk today about data governance and sharing for Lakehouse. I'll talk about some things we're doing on the Databricks platform, as well as a lot of work we're doing in open source with the open source Delta sharing project. So let me start by talking about governance. So anyone who's had to do it knows that governance for data and AI today is very complex because of the very complicated technology stacks involved with multiple different systems. And by governance, just to be clear, I mean controlling who has access to data, auditing that, and in general understanding how data is used in your organization. And so one of the big challenges is that there are so many different technologies involved with different ways of doing governance. For example, in a typical enterprise today, you'll have a lot of data in your data lake. Think something like Amazon S3. And if you want to control permissions on that, you can set permissions at the level of files and directories. Now, this is already a bit of a problem because it means you can't set fine-grained row and column permissions. And it's also very hard to change your model for how you organize data. You have to move all the files around if you want to change your directory structure. So that's already kind of awkward. Now, on top of that, you probably want to think of your data as tables and views. So you might have something like Hive Metastore, where you set permissions on tables and views. And it sounds great, but the problem is those permissions can be out of sync with the underlying data. And so that leads to a lot of confusion. And then you also have your data warehouse. You have richer ways of setting permissions there, but it's just a different governance model. You set it all up in SQL with grant statements. And then you have many other systems like your machine learning platform, dashboards, and so on, that each have their own way of doing permissions. And you have to somehow make sure your policies are consistent across all of these. So a year ago at Data AI Summit, we announced a major new component of the Databricks platform, Unity Catalog, which gives you a unified governance layer for data and AI assets. And the idea is really simple. For all the kinds of data assets you can create in Databricks, we have one interface for managing permissions, managing auditing, and so on. And that's Unity Catalog. And when designing this, we wanted to make the interface to set the permissions and to manage it very open. So we actually chose to base everything on ANSI SQL grants. So anyone who's administered a database, any tool that knows how to set permissions in a database can use Unity Catalog to manage all these assets. And we also set up centralized auditing and lineage. So last year we were just starting, to roll out this product. We're still developing it very actively. And since then, we've added a lot of functionality to Unity Catalog. So I want to tell you a little bit about some of the new things we added and what's coming next. So first of all, just how do you use Unity Catalog? So this is the most basic thing you can do with it. You can set up access controls. You can set them up using standard SQL. You can use a REST API or UI as well. And we've extended this beyond tables to other kinds of objects, like, for example, files in your Cloud Object Store. And we do that in a manner that's consistent with the permissions you set on tables. And we also have really easy access to audit information. It's just a system table that you can read with all the actions. So very easy to see everything happening on your Lakehouse. Now, beyond that, we have built-in search and discovery. It allows you to quickly search, document things about all the data in your organization in the UI. And we also have a really powerful lineage feature that we've just launched. So this allows you to set up, to track lineage on tables, columns, dashboards, notebooks, jobs, basically anything that you can run in the Databricks platform and see what kind of data fed into each one and who's using it downstream. So it's very useful for understanding how data is used, fixing issues with data, and so on. So to show you a little bit of this in action, I'm actually going to do a short demo of just the lineage feature. So I'm going to head over here and log in to do that. Let's see. All right. So yeah, I think if you can show that on the screen. OK, great. So yeah, so I'm here in Databricks. This is just one of our, like actual deployed environments. And I have a little notebook that's going to process some wind turbine data. And just going to get this running. So you can see this has a Python command at the top, and then a SQL command. So the Python command is taking data from 3 tables and joining it together to create this table called turbine master. And then the SQL command is creating a new table, turbine features, based on some computation based on this, this command over here. And so, they're just arbitrary code. The lineage feature we have works with any computation you do in Spark in any programming language. So now let's look at the data explorer here and try to find this data. So this is the table I created, turbine master. And you can see here all this information about it. You can set permissions on it. And there's also a tab for lineage. So one of the things you can do is see the lineage graph. And this is actually computed in real time as you do work on Databricks. Yep. So, yeah. So yeah, so what you see here, this table was created by combining 3 other tables, and then it was used to produce one thing. And you can even click on these guys and see what's producing each of these upstream. So we connect all this information as you do computation on the platform. And beyond that, the lineage also extends to individual columns. So for example, for this column, I can see where it came from upstream, and I can also see downstream it's actually used to compute 2 columns in this features table. Yeah, and it even extends to notebooks. So I can see this notebook was used to create the table, and there are also a whole bunch of notebooks using it. And that's useful, for example, if I ever change the table, I want to know which users I'm going to impact by doing that. So that's lineage in Unity Catalog. So switching back, let's switch back to the slides here. All right, so that's just one feature of Unity Catalog. We've also been working to integrate Unity Catalog with partners across the modern data stack, and we have integrations with many best-in-class tools. So this includes advanced governance tools that can set sophisticated policies across Databricks as well as other platforms, and also leading products in data ingestion, BI, and data pipelines. And we also had a bunch of customers using Unity Catalog and giving us great feedback. So here are just 2 examples. Block is using us for financial data that they process, and Milliman is using us for healthcare data. And in both cases, it's really simplified the way they manage data at scale. So today, I'm really excited to announce that Unity Catalog is GAing. We'll be rolling out GA in the coming weeks for Unity Catalog. Yeah. So yeah, very excited to see what everyone does with it. And we also have an exciting roadmap ahead. Some of the big things we're working on include attribute-based access control. This allows you to set tags on all the kinds of objects you can have in Databricks, and then set a policy that applies to anything with a specific tag, like say all your data tagged finance, including dashboards, models, all that stuff. And we're also working on easy row and column filtering within a table to show people just different pieces of it. So that's Unity Catalog. That's one key step towards maximizing the value of data in an organization, is actually being able to govern it inside it. But with Databricks and the Lakehouse, you want to look at all the ways you can maximize the value of data, and there's a lot more that you can do. So for example, a second important pillar to really using data effectively is sharing data between organizations, and we support that through the open source Delta sharing project that we started last year at this conference. So I'll tell you a little bit about what's new with that. So first of all, why is data sharing important? Many organizations are now starting to share data either with partners, so just to improve a common business process, you can share details about like what you're doing together. But also many are starting to monetize data. And Gartner, for example, says that they expect 3 times better economic performance from companies that share data and are part of an ecosystem. And they also see 50% more of these ecosystems starting just by next year. So today you can do data sharing in a number of proprietary platforms, mostly data warehouses, but there are a lot of problems with using these. So we talked with many data providers, many data consumers, and they all had some challenge with these. And the issue is that the sharing is only within one technology platform. For example, in BigQuery, you can share data with other BigQuery customers. And in Redshift, you can share data with other Redshift customers. But if you ever want to share with someone on a different technology platform, it's a problem. And this is a big issue for data providers because you work hard to create a data set, and now you have to copy it into 5, 10, 20 different systems just to reach all your users. And you want to reach as many users as possible with minimal maintenance overhead. So the problems are because you have vendor lock-in here, the only way to actually reach a lot of users is through expensive replication and maintenance of all these data sets. So when we looked at data sharing, we took a very different approach based on open source. So last year at the summit, we created Delta Sharing, an open standard for data sharing. And it's a very simple REST API that any platform can implement. And basically, any system that can process Parquet can read data through Delta Sharing. The way it works is the provider has a Delta table in cloud storage. They can run this server in front of it and add users. And then the users can connect with any client. All the ones I'm showing there, like Pandas, Apache Spark, all have plugins. Power BI has a plugin to read from Delta Sharing. And then those can process it anywhere they are. They don't have to be on the same software platform. And the transfer is efficient because it uses a feature of cloud object stores that allows you to give someone temporary access to read just one file. So you don't have to stream all the data through the server. It's actually really fast. So now you get cross-platform sharing. You publish your data once, and people can consume it from anywhere. And you can share your existing large-scale tables without copying them into a different system. So at the last summit, when we announced this, we were just putting up the GitHub repo. Like, it was literally empty 2 or 3 months before the conference. So it was a brand new thing. So we didn't know how this would do. And we've been very excited with the growth of the community since then. Actually, today, there are petabytes of data exchanged using Delta Sharing every day just on Databricks alone. And this is, yeah. So this is data that's actually read and processed across organizations. It's not just people publishing stuff. And here are just 2 examples of customers that are using this. So NASDAQ is using Delta Sharing to monetize very large data sets they have that they couldn't share through legacy platforms. They were just too big, too expensive, but they were just sitting there in Amazon S3 in an open storage format. So now they can actually monetize those. And then Shell is using it to exchange massive data sets within the energy industry where a lot of companies want to coordinate on fine-grained data to improve their processes together. We've also added a lot of new things in the open source project. You can see a lot of new connectors. We started with just Pandas and Spark, and there are many that have been released and are in progress. We added a feature called Change Data Feed, very popular feature from Delta Lake that lets the consumer see what changed in each release of a table, makes it much easier to consume shared data sets. And also for Databricks users, we added very easy one-click sharing with another Databricks account. Just put in their account ID, and you can share a table with them. And we're also excited to announce that Delta Sharing is GAing, and it's going to roll out in the coming weeks. Yep, and like Unity Catalog, we have an exciting roadmap ahead. Two of the big things we're working on are sharing views, which allow you to do fine-grained data filters and other computation before you send the data to someone, and also sharing streams, so someone can consume a table as a stream to do real-time processing on, on data across organizations. OK, so that's data sharing. We think it's really important for maximizing the value of data. And so today at the conference, we're also announcing two brand new efforts that built on delta sharing to further expand how organizations can use their data in today's ecosystem. And these are the Databricks Marketplace for commercializing your data and Databricks Cleanrooms for private computing. Cool. So yeah, so let me just briefly explain each of these. So I'll start with Marketplace. So we looked around, and many cloud providers offer data marketplaces. But when we asked users about these marketplaces, such as data providers, they actually, they don't use them that much. And they said there were a couple of limitations. One limitation is that each marketplace is closed. It's for a specific cloud or a specific data warehouse or software platform, because the goal of these from the vendors is to get more people computing on their platform and paying them money. And so that's nice for those vendors, but if you're a data provider and you worked hard to create a data set, it's really annoying to have to publish it to 10 different platforms just to reach all the users who want to use your data set. So it's a problem. And then from the user side, one of the challenges is these are just limited to publishing data sets. So you go in there, you see a table or a file, and you can pay $50,000 to get it or whatever. But what are you going to do with it? What if it's not useful to you? Like all you get is that table, then you have to figure out how to use it. So it would be nice to share, more than that, to share kind of entire applications or solutions. So we wanted to rethink the concept of data marketplace. We think what people are looking for is a bit more general. It's sort of a solution marketplace. And we also thought it's really important to be open. So as a publisher, you publish stuff once, and then people can consume it everywhere. And that's what we're doing with Databricks Marketplace. It's an open marketplace for data solutions that's built on delta sharing. So any client that can read delta sharing can actually access this marketplace. And this has some really nice benefits for both providers, reaching more users and publishing more complete applications, and for consumers who can actually get started with something that includes not just data, but code, notebooks, ML models, dashboards, examples of how to use the data. And we've set it up so pretty much anything you can build on the Databricks platform, you can publish on the marketplace to give someone a complete application. So to demonstrate Databricks Marketplace, I'd like to invite Zaharia Valani, our Senior Director of Engineering for this area, who's going to give you a demo. Oh, you're there. Hey.
Thank you, Matei. I'm so excited to introduce the Databricks Marketplace, an open marketplace where all the data and AI assets are in one place to help you get to insights faster. So how does it work? Let me walk you through it from the perspective of an end consumer. Let's imagine that I'm a data analyst working on an acquisition in the retail space. I need some data on purchasing trends, and I need it right away because we're in a competitive situation and we need to make a decision soon. Here in the Databricks Marketplace, I can already see a variety of data products ranging from financial data products from providers like NASDAQ to healthcare products from providers like IQVIA. Below the featured providers, each tile represents a data product. A data product includes not just packaged data sets, but it can also include dashboards, notebooks, and even machine learning models. And I can search across all these data products right here. So let's put in retail. Let's take a look at this data product from Data, a leading market research data and insights firm. It looks like something that I can leverage, but I want to learn more. Let's take a look. In the product details page, Data has provided an overview of the data product, and some potential use cases to help me learn more about the offering. I really need to speed up my understanding of this data set. So how do I do that? Yipit Data has also included a notebook with some examples of working with the data. Let's take a look. Oh, wow. Here are some example visualizations and analysis of the data. This is so helpful. Before, I would have spent days trying to get these types of insights. This notebook has really helped accelerate my understanding of the data set, and it's given me a head start to start thinking about how this can apply to my use case. But there's more. Here, on the top right, I can navigate to a live dashboard of the full data set. I'm getting to do all this exploratory analysis before I get the data. That way, I can be confident that it's what I need for my use case. And this dashboard could be really useful to my organization on an ongoing basis. Now that I'm confident that I want to use this data, let's go back to the marketplace and we'll get the data. There's a catalog telling the marketplace where to provision the data product, and I'll also get the dashboard and the notebook. And I'll get data, and in less than a second, I now have access to the data. Behind the scenes, when I clicked on Get Data, the provider is automatically provisioning the Delta share in my workspace, and the dashboard and notebook are deployed into my workspace. And so now the provider will also be notified that I requested access to the Delta share, and they can follow up with me as part of the evaluation. I can click on the notebook and continue on with my analysis. Even if you're not a Databricks customer, you can still go through this entire workflow. The Databricks marketplace is not just for Databricks customers. It's open to all. What this means is that if you register for an account, you can log in and browse and access the marketplace. And because it's powered by the Open Delta Sharing Protocol, you can use the tool of your choice. So for example, if you're a Power BI user, Power BI can connect directly to the data provider using Delta sharing. Consider what we just did. With the Databricks marketplace, you can search across a variety of data products. You can use descriptions, notebooks, and dashboards to quickly evaluate if it meets your needs. And you can get the data and related assets delivered to your workspace without having to configure or build any data ingestion. Stay tuned for more details on the Databricks marketplace later this year. Thanks.
Great job, Zaharia. All right, thanks so much, Zaharia. Yep, that was really cool to see. So this is the first open marketplace for data and AI in the cloud. We already have some awesome partners with the marketplace, as you saw, and we're excited to see what everyone else will do with it. So if you can switch back to the slides. OK. There we go. OK, so the last thing I want to cover here is private computing with Databricks cleanrooms. So what are cleanrooms? If you're not aware of the term, they're an emerging concept that a lot of organizations are starting to use to run computations on joint data. And basically, they're a way to set up a secure environment where different owners of data sets can put in data sets of their choice and run computations that are mutually approved by everyone involved. So for example, if you think of a retailer or an advertiser, they may have a lot of questions about how campaigns are doing together, but neither of them wants to give its full data set to the other one. That's very risky. But they could set up a clean room to run a specific computation. And same thing applies, say, to two banks that are trying to detect fraud together, and many other use cases. Now, clean rooms have existed for a while, but the existing solutions have a couple of drawbacks. A lot of them are just built into SQL-only systems. So the only things you can do in the clean room are SQL, and this isn't enough for more advanced analytics like machine learning, graph processing, the things you need for a lot of the use cases I talked about. And also, these are these proprietary platforms where you have to copy all your data in. So for small data sets, maybe you can copy them in and do this stuff, but if you have massive, petabyte scale data sets in cloud storage, you can't do that. It's very expensive. So at Databricks, we actually happen to have technology that can address both these platforms, both these problems. First of all, we have a cloud platform that lets you run the very best open source data and AI tools, and we can run it in a serverless, automated, and secure fashion. And second, we have Delta sharing, which lets you securely share access to some of these large data sets. So this is what we're using in Databricks Cleanrooms. It's a simple cleanroom solution that allows you to run any kind of computation that the Databricks platform supports on existing Lakehouse data. So if you have parties involved in a cleanroom, they can mutually agree to create a cleanroom, they can each share some tables into it, and they can each approve jobs. And it's got 3 benefits. The jobs can be arbitrary computations you can run on Databricks. They can use Python, R, SQL, GPUs, TensorFlow, whatever you want. You can run it in your cleanroom computation. You don't need to replicate your data, and they're scalable to large number of collaborators and large data sizes. So we're just getting started today with this feature, but we're very excited, and we'd love to hear about your use cases for it. So that's it for governance and sharing on the Lakehouse. We now support 4 really important ways of maximizing the value of the data. And the really cool thing to me is that we're doing all of these following the Lakehouse philosophy. So they all work with existing data at massive scale in open format, and they all have open interfaces. That means it's not just Databricks, but a wide variety of computing platforms that can participate in these. And we're very excited to see what you do with them. Yeah.
All right, that was amazing. So we now have Unity Catalog that lets you govern all your resources, not just tables, not just files, any data asset, machine learning models. So that's fantastic. You can lock things down. You saw the marketplace. I'm super excited about that because it's an open marketplace. It's actually the only open marketplace where you don't have to be a Databricks customer to use any of the data assets that are shared there, and you can actually share all kinds of data assets, not just tables. It could be dashboards, it could be apps, all kinds of things. So super exciting. And then the clean rooms for people who don't want to share the data set, but they want to have a way in which you can actually run computations on the shared data sets. So that's super exciting. OK, so next, I want to welcome to stage Tristan Handy from DBT Labs. I'm very excited about this talk because Tristan essentially created a new persona. So the analytics engineer didn't really exist before DBT Labs and DBT and Tristan. He basically enabled a whole generation of data analysts to become engineers and do what otherwise just only data engineers could do. And the reason I'm really excited about this is that I think actually these worlds are merging. I think the world of data analytics and analytics engineering and data engineering and data science are getting closer and closer together. People will do more Python, more machine learning, more data engineering. So with that, really excited to welcome Tristan on stage. Tristan.
Wow, it's great to be here. I come to you from a far-away land, the world of the data analyst. This is a world that I know and love. As a data analyst, I deeply understand the businesses that I work at. I understand how to observe their performance and diagnose their problems using data. I write a lot of SQL and a little Python. I brainstorm in dashboards, and sometimes I even make a spreadsheet or two. I'm not very opinionated about my tooling. It's all about getting the job done. But over the past 6 years, I've become very opinionated about my workflow. Let me take a minute to tell you that story. 6 years ago, data analysts created a ton of one-off artifacts. SQL queries that got saved on a laptop, spreadsheets that were fragile and broke, and dashboards that became out of date as schemas changed. This didn't really feel like anyone's fault. It was just the way that things had always been. But I hated this. I really hated this. It meant that data analysts just weren't as effective as I knew that they could be. I had worked in software companies for a long, long time, and I understood how software engineers created leverage. They wrote modular, tested, scalable code. They checked it into source control. They deployed it with CI/CD pipelines. And they treated it like an asset, not like some waste product. They also built cultural norms around the stewardship of this code. They practiced Agile and DevOps and SRE. The result is that software engineers operate with leverage. Experienced software engineers are some of the best paid professionals in the world. And it's all because of this set of tools, norms, and practices. I felt left out. I wanted to work like this as a data analyst. So, back in 2016, my co-founder Drew and I built this little open source tool called dbt. Our goal was to help people like me author and deploy modular code inside of cloud-native data platforms. At the outset, really, truly, nobody cared. I wrote this big manifesto back in 2016 about how analysts' work needed to change, and it was received with crickets. It's not that anyone disagreed. It's just that this entire train of thought was like completely foreign to the analytics ecosystem back then. But slowly, a small community of like-minded folks came together. By the end of 2016, there were a whole 100 of us. And year after year, new practitioners got exposed to the power of bringing software engineering practices into analytics. They got excited about how this could impact their work and their careers. Today, there are over 30,000 of us in the dbt community. And there are over 12,000 companies using dbt in production. Somehow, something happened. An entire ecosystem turned onto the idea that their work could be done differently. Early in this journey, we realized that we needed a name for this thing that we were doing. It wasn't data analysis, but it also wasn't really data engineering. Or at least, it wasn't data engineering done the way that data engineers had traditionally thought about it. The community settled on the term analytics engineering. Here's the definition that Claire Carroll uses in her 2019 article. Analytics engineers provide clean data sets to end users, modeling data in a way that empowers them to answer their own questions. Empowers them to answer their own questions. I think of analytics engineers like librarians. A librarian's job is to make sure that knowledge is well organized, that folks with questions can find answers. What we realized was that this hybrid persona, the analytics engineer, was the missing link on the modern data team. And the entire industry is waking up to that. As of today, there are over 500,000 analytics engineers in the world. up from basically none in 2018. Here's how we see the most high-functioning data teams working today. Data engineers are responsible for building and maintaining scalable systems, and they also are responsible for landing data in the Lakehouse. Analytics engineers are responsible for taking that source data and transforming it into usable data sets. Data analysts are responsible for insight generation. But really, this is an oversimplification. Anyone who works in data knows that these lines are never this clear. These roles overlap with each other all the time. The real secret to a high-functioning data team is making sure that team members with all kinds of skills and backgrounds can collaborate together. Which is why dbt was designed from the ground up to feel comfortable for the data analyst while scaling to meet the needs of data engineers. It's the one tool that all data practitioners can collaborate in to build their knowledge graphs. Before wrapping, there's one more thought that I want to explore with you. The world that I've been talking about so far is a world of counts and sums and standard deviations. It's descriptive. It asks what already happened. But that's only half of what this conference is about. One of the biggest problems, and Ali alluded to this, in data today, I think, is the lack of collaboration between my world, analytics, and the world of AI and ML. I'm excited to be here with you because I think these worlds are converging. Ali kind of stole my thunder. I think that, honestly, I think Databricks is doing a ton of great work to make this happen. With the launch of Delta, whether you're looking for the ACID compliance of a warehouse or the unstructured qualities of a lake, you got the best of both worlds. With the launch of Databricks SQL, you now have a high-performance, managed way for your data analysts and your analytics engineers to access all the data in your Lakehouse. So, Databricks, thank you for inviting me and data analysts like me to the cool kids party. At DBT Labs, we are also pushing to unify the worlds of analytics and ML. This year, we're making huge investments in supporting Python-based data science workloads inside of DBT. Thank you. I'm excited too. I'm not quite ready to show a demo, but we are innovating in the open, and we'd love your input. Ultimately, analytics and machine learning are just two methods of problem solving. We believe that all data practitioners should be able to use consistent tooling throughout this entire spectrum. We're excited to partner with the entire Databricks ecosystem to bring this to reality. Thank you so much.
Thank you so much, Tristan. That's super cool. So I presume we're going to see more and more ML, Python, and other things inside DBT, and that's super, super exciting. OK, so I want to now welcome to stage a man who's been doing data warehousing essentially his whole life. He's essentially our CTO of our data warehousing solution. So welcome, Shant, Hovespian, to stage.
Hi, everyone. It's really great to be back here in person. I'm Shant. I'm a software engineer working on Databricks SQL. And later on, I'll be joined by Miranda Luna, who's a staff product manager working on Databricks SQL. So what has happened in the 3 years since Databricks announced the Lakehouse? Petabytes of locked-in data all alone in the data warehouse were set free to be shared and interacted with in the Lakehouse. Millions of business questions hopelessly unanswered in the data warehouse were brought to the Lakehouse, where machine learning models found the answers. So it should be no surprise to anyone here that the Lakehouse is great for open access to data and sharing. And of course, integrating predictive analytics. But as Ali pointed out earlier, Lakehouses are great at data warehousing workloads as well. So how is it that we got the value of the Lakehouse to surpass that of the data warehouse? Databricks SQL. This is our SQL warehouse offering on top of the Lakehouse, where we've been focusing on connecting to your data stack, bringing together the best of data lakes and data warehouses, and obsessing over value with performance. So let's talk a little bit about how we connect your data stack. With Databricks SQL, we wanted a first-class SQL experience that you can use for ingestion, transformation, and consuming your data with any tool out there. For data ingestion, we work great with Fivetran to bring in data wherever it lives. This can be Google, Marketo, Salesforce data, or just files sitting in object storage. You heard Tristan just talk about analytics engineering, and we've been working really hard to make sure that DBT integrates amazingly well with Databricks SQL so you can run your DBT projects and pipelines. And of course, data consumption, because what good is data that you're just loading and transforming if there's no way to get it into the user's hands? So we've gone and worked with all of these BI vendors to make sure they're all Lakehouse certified. But data is critical, and sometimes just looking at a chart isn't enough. You need to integrate the data into your business and applications. So today, I'm very excited to announce Connect from Anywhere. This is our initiative to make it simpler to connect and bring the data in the Lakehouse into your custom applications. This will be a SQL REST API in preview, open source Go, Python, and Node.js clients so that you can connect this data with the applications or languages that you love the most. Let's talk about how we brought together data warehousing and data lakes. So Databricks had always been wonderful at letting you put Python and SQL together for your machine learning models. But from SQL directly, the times where you want the flexibility of Python. And so with Python user-defined functions, we're now in preview bringing that functionality to all of the SQL users so they can take the power of Python and bring it into their SQL environments. You can sign up for the preview at this link. Query federation, right? The Lakehouse is home to all of your data sources no matter where they live. And now that's true more than ever with the introduction of query federation in Databricks SQL. You can connect data sources directly, join them with other data sources, join them with the data in the Lakehouse. All of this is automatic and transparent, and our optimizer will make sure it's efficient execution. Materialized views. These are essential for accelerating common query patterns. And these aren't your grandmother's materialized views, mind you. They're powered by Delta Live tables using the underlying streaming architecture that Karthik explained earlier to make sure your data is always fresh and up to date. Data modeling with constraints. Now you can have informational primary and foreign key constraints to define the relationships between your data. You'll have identity columns that are automatically generated for you. And very importantly, enforced check constraints so that you don't ever have to worry about data quality or data correctness issues, again, when working with your data. So let's talk about performance. The journey to Photon. You see, all of this that we're talking about is in the cloud. And in the cloud, time is money. The faster something runs, the more optimized it is, that's savings. And with Photon, it's our next generation query execution engine. It's MPP execution written in native code, leveraging vectorized CPU primitives, which is just a fancy way of saying it's really fast. In the chart here, you can see with every release of the DBR runtime, since 1.0, we got faster and faster in the early days, but eventually it just became hard to get faster, and we knew that we needed something new to get to that next level of performance, and that was Photon. Since we've introduced it, it's processed exabytes of data and billions of queries. Our customers have seen 3 to 8x interactive workload performance improvements. They've run ETL jobs at 1/5 the cost, and on average, a total cost of ownership savings of 30%, and in some cases, up to 80%. And we talked about SIGMOD earlier, the conference where we got the Spark Chief Systems Award. We also shared all of the details and inner workings of Photon in a paper a couple weeks ago, and we're really humbled to receive the Best Paper, Industry Paper Award at the conference. Yeah, it was great. So our customers love Photon, and it's winning awards, and I think it's about time, I'm very excited to announce that Photon is now generally available on the entire Databricks platform. Spark-compatible APIs to accelerate all of your workloads. All right, but what else in performance? This chart on the left here, it shows TPCDS at 100 terabytes. TPCDS is an industry standard benchmark for comparing the value of data warehouses. You can see that Databricks SQL, compared to all of the other CDWs out there, has up to a 12x performance improvement. This is huge. You can read more details about it on the link below. But I really, really want to focus on the chart on the right, because this is something where we've shown that Databricks SQL can be amazing for large workloads, large data sets. But this is TPCDS and a variation of that benchmark, which is an official variation, where you can run 32 concurrent streams of users constantly hammering queries against the system. And what you do is you measure the throughput of that. And you can see over the last 2 years, we didn't start great, but it's gotten 3x better, meeting and if now exceeding all of the other cloud data warehouses. And so let's focus here for a second. Because what is it about queries on small data sets that's so important? Well, so query compilation, when you're running a query, one of the things you first have to do is compile a plan of how to run it. So let's look at this simple query over here. Select AB from T, where C between 5 and 23, limit 1,000. Before we run this query, we sort of need to figure out, hey, what's the best way to run it? And in this case, we ran this query on a small data set, and this is kind of what the timeline looks like. You can see the compilation phase has something pretty involved in it called analysis. This is where we check all the column names, references, and types, make sure they're correct and there's valid metadata. There's the optimization phase. This is where we check the transactional semantics, make sure everything's correct, figure out an optimal way of distributing the work across the nodes. But it's very unintuitive. Sometimes just generating this plan took longer than actually executing and processing the bytes. So here you can see it was about 1.8 seconds to compile it and just 300 milliseconds to execute the query. So we've worked a lot on this problem. And very soon we're going to be releasing the next version where we've optimized Delta, reduced some of the redundant operations in this pipeline, and even some of those operations now run directly in Photon, leveraging the power there. And so we got this query to run 2x faster. But that wasn't enough. We didn't want to stop there. We've got another feature we're working on called metadata pipelining, where we get that box about file listing, because it's a lakehouse, an open lakehouse after all. So data can be coming in from any data source at any time, and we always need to check to make sure we're working on valid sets of data. Instead of waiting for the entire file list to get generated, which can take a long time with things like Parquet, with partition tables, lots of files, what we're doing is we're overlapping the execution and compute while we're streaming the file results out. And then in this experimental system with this query, we further reduced the runtime by another 300 milliseconds. So it's very exciting, and that's not all. There are tons more performance features we're working on. We have a long history in obsessing over sort. In 2014, there's this thing called the gray sort challenge, which is measuring which system can sort 100 terabytes the fastest. And we won in that year. And since then, we've been like, okay, we got to come out with a better version of sort, and we're doing that soon. But everyone's like, don't you just need sort for order by? Like, what's the big deal here? And while that's true in a data warehouse, when it comes to the lakehouse, machine learning and streaming workloads rely on sort for a core primitive. So when we went to make it go faster, we also had to make sure we could handle different size keys, variety of data, unstructured systems. So we've put a lot of work in here and really excited that this will be in preview soon to accelerate all sort workloads regardless of the use case. We're adding accelerated window functions to make these operations run faster. And when it comes to reading and scanning data, we've added vectorized kernels to process all the open formats quickly and adaptively deal with all the cloud systems. But I just bombarded you guys with features. The Lakehouse is great. It's time to show you why it's so great. And I'd like to welcome Miranda to do a quick demonstration.
Hello, hello. I am very excited to be here today to show you how the Lakehouse is your best data warehouse. And also we can just double check and make sure Shant's not lying to us about any of these new announcements. So today we're going to do three things. We're going to start with some NYC taxi data. It's just data that has some information about trips, how long they were, what the fare amount was, starting, ending zip codes. And we're going to start by doing some classic data warehousing. We're going to look at our favorite BI tools. We're going to make sure that we can explore and visualize the data. But then we're going to transition to some of the new and exciting things that Shant just announced. We're going to look at query federation. We're going to look at some OLTP transactions, and we're going to show how we can actually leverage those in the same query as one against our historical data in the Lakehouse. And then last but certainly not least, we're going to take a look at using our colleagues in data science gradient boosting model right alongside my query of historical data via a Python UDF. So let's go ahead and get started. Awesome. So right here, what you see, we're starting with a stopped serverless SQL warehouse. This serverless SQL warehouse, I went ahead and pre-configured it to have scaling up to 5 different clusters. That'll come up a little bit later. And what we're going to start with here is actually taking a look at this data using this serverless warehouse in Tableau. So let me go ahead and switch over. OK, perfect. I will enter my password. And as this is logging in, let me just hit sign in. What's actually happening under the hood is this is going to go ahead and load up my dashboard that I already had here. And what that's going to let me do is actually start that serverless SQL warehouse under the hood. Should be up and running in seconds. Yep, there we go. And now we've got our data. I'm going to go ahead and do a quick filter just to make sure that we can actually query it live, our data in the Lakehouse. Yep, that went ahead and adjusted. Perfect. And again, I'm using Tableau right now, but let's just take a quick peek because certainly you can use any of your favorite BI tools, whether that is, and we can see it started, whether that is Power BI, whether that is, if I just swap over, Looker. We get to benefit from a couple different color themes here. Certainly also, we have a connector for ThoughtSpot, have a number of customers using that, and Sigma. Now, of course, me doing one user, one dashboard is exciting, but not realistic. So why don't we actually try to scale that up and see if we can support hundreds of concurrent users. I'm going to go ahead and switch over to this notebook, where I'm going to go ahead and pop in 200 concurrent users. What this is going to do is essentially jigger the query that we had in that dashboard before. And that's going to essentially change all the parameters for those 200 users I entered so that we have unique queries, nothing's cached, nothing is speeding up. And we're going to see if we can get those clusters to pop up to what we looked at, the max 5 that we had set on our auto scale. So, yep, nothing too fancy, just a little scale test. So let me switch back over, and we'll go to the monitoring page. We kick that off. We can see we're still at kind of that one cluster, normal size, great. Let me kind of flip this timing. All right, great. Now we're up to 5, and we can see that we're running many more queries concurrently. So from here, we can see that we've already scaled to support 200 concurrent users, whether those are in Tableau, Power BI, et cetera. But why don't we actually take a look at some of this data directly into Lakehouse? Databricks SQL provides a built-in SQL workbench where we can actually query this data, visualize it directly without having to go to a BI tool, just so that we can do some quick spot checks. So here I'm going to take a look at some actual fares, all trips under 10 miles from a couple different originating zip codes. Let's do a quick spot check and make that scatter plot again so we can make sure that the data looks exactly how we expect. So we'll flip to scatter. We will quickly go ahead and pick distance. And we'll also do our fare amount. And then just so we get some different colors, let's go ahead and break that out by day of week. Should look pretty similar. Yep, check. So this is great, but I promised I would show you a little bit more about what Shant kind of just announced. So actually, why don't we start by kind of looking at some recent transaction data that's stored in Postgres in a different system. So I'm going to switch over to this other query. So in this query, I've actually already set up an external table that's going to allow me to query a Postgres in an external system. This is just going to be kind of recent OLTP transaction data, but what this is going to allow me to do in a second, and that's just my secrets, it's going to actually allow me to use the data stored in the Lakehouse in the same query as data external. So let's just do a quick gut check and make sure we have data in that table, that external Postgres table. And then the next thing we're going to do in that second statement you see here after this finishes is we're going to actually filter the data in the Lakehouse based on what we see in that Postgres table. So here I'm going to say, only show me the trips where that meet under the minimum distance from what I've seen recently. And just like that, we're going to have now updated our view of data in the Lakehouse based on what we see in our most recent transactions in Postgres. Pretty exciting. All right. And now, again, I want to switch over. We're a data and AI company, right? So we have to do some AI. This is a gradient boosting model that I'm just going to scroll through real quick. One of my colleagues on the data science team built, but I'm going to go ahead and invoke that in a SQL query directly via Python UDF. So you can see here, we're just kind of building a couple data frames. And if I switch back over to the SQL editor, this is something that I, as an analyst, would have not been able to do before, is to leverage that gradient boosting model. So this first statement that I'm highlighting just shows the actual fares, same thing we just looked at, trips under 10 miles. But this down here, you're going to see we're actually using it to predict fares for trips we don't have historical data for. So trips 10 to 12 miles, I'm invoking that Python UDF. All it needs is the pickup date time as a float and the trip distance for me, and I'm going to go ahead and run that. I've also appended a column so we can quickly tell what's actual and predicted, and do a gut check that everything came out as we expected. So let's just take a quick peek. It looks like we have actual and predicted. So we have now been able to generate forecasted fares directly in the SQL workbench based on a Python UDF my colleague wrote. And over here, I just kind of updated our tried and true scatter plot, and you'll see I'm highlighting the predicted fares in red. And those fares are, again, generated by virtue of using that Python UDF and the gradient boosting model. And then here I have my classic view of the scatter plot we did to start. So seamlessly, I was just able to leverage not just my historical data, but also use that to invoke a model that has been written by one of my colleagues, and I can forecast fares for trips that I haven't had historical data for just yet. So hopefully that was a pretty exciting way to see that Shant is actually telling us the truth. We like to do a small gut check on Mr. Shant, but yes, we are so excited about all the announcements today and all the progress in the past year. And thank you for coming along with us on this journey. There are even more exciting things to come. So with that, I will let Shant take a little bit more thunder. Thank you all.
Thanks, Miranda. Oh, wow. So, if you guys noticed, Miranda was able to quickly start up that endpoint, run her queries, and most importantly, when those 200 simulated users came in, that cluster auto-scaled nearly instantly. And that was with Databricks SQL serverless. And so with serverless, your users get instant auto-scaling capability. Your admins don't need to worry about management, pools, reserved instances anymore. They get simple and predictable pricing. And of course, for budget, it's a reduced total cost of ownership. So very excited to announce today the preview of Databricks SQL serverless on AWS. This means every single Databricks SQL user out there on AWS can log in right now and enable serverless and benefit from the amazing features we showed here. And don't worry, everyone on Azure or Google, it's coming very soon to you as well. So this is the Lakehouse, where the best data warehouse is always a Lakehouse. You can visit this website to get started. Thank you very much, everybody.
All right. That's awesome. So you saw the benchmark results earlier that I shared. Shant showed you how that's done. Okay, so under the hood, all the optimizations, all the things that they did to make that happen. So that's super cool. And we saw that Miranda also verified that everything he said is true. I always do that with him as well. So cool. So we're running a little bit late, but we have one last speaker. So please stay tuned. So I'm super excited to welcome on stage Kerby Johnson from Amgen. Amgen is a really exciting partner of ours. I actually remember one QBR that we had where Kerby was there, and we were talking, and they said that for them, the thing that was so exciting was that as an IT organization, they were able to actually start impacting the business in a really strategic way, and that was actually helping, save lives and actually make it much more interesting than, what things had been like, say 10, 20 years ago. So I'm super excited to welcome him to stage. Kerby, welcome.
Thank you. I'm excited to be here, and I know right before your break, so I will be hopefully short and sweet, but interesting. And so let me tell you a little bit about Amgen and our journey towards the Lakehouse. So at Amgen, our mission is to treat grievous illness. In technology terms, you can view us as a full-stack tech company. We do discovery of new drugs, we take them to development, we manufacture, and we market it. And the focus is on grievous illness. And we are one of the oldest independent biotech companies. We're global scale, 25,000 people, 25 billion in revenue. We have 6 therapeutic areas we focus on. So cancer research, which is oncology, bone health, inflammation, et cetera. And we have 25 products that are very focused on that in the grievous illness, and we have millions of patients worldwide. So what does that mean? For us, data's at the core of how we discover, develop, and deliver life-changing treatment. And data is incredibly variant. So in discovery, you're working with molecular data or genomic data. In clinical trials, it's about real-world evidence of how is it behaving in the real world. And then when you move into manufacturing, it's sensor data and IoT and so on. And so you need to be able to combine across these variant data sources in order to actually deliver questions. And so what are the questions that really matter to us? There's a 2020 study that said development of a drug is still taking 10 years and $1 billion to go from discovery to market. We're trying to make that shorter, faster, cheaper, just like every other drug company. But how do you do that? You do it with technology, you use it with data. And so we're starting to answer these critical questions, but we need to be able to answer the most important ones, which go not functionally oriented, but cross-functionally, so that it meets the different users and the different personas and the different types of data. It doesn't do any good to develop a new drug if you can't actually manufacture it. So you need to be able to combine across the two. And that is where we're starting to use the Databricks Lakehouse. We've been a Databricks customer for about 4 years. We have 2,500 monthly active users. We have an extensive number of data science projects, and that varies anything from a short-scale data science project that's a few weeks to answer a very specific question to a team of 5 to 10 data scientists who might be working on a project for 6 months. And the question and what we're trying to do is really self-service enablement with guardrails and with control, and that's where we're leveraging Databricks. Our journey has been very similar to probably many customers. We started with a data warehouse. We went to a Hadoop-based ecosystem, both on-prem and in AWS. That gave us a lot of value. But then we started to get in the scenarios of you needed to do weekly processing and spin up 400 machines to do weekly processing in time. We couldn't do that with a Hadoop-based ecosystem, so then we moved to Databricks with elasticity. In the last few years, we've been focused not on just the data lake, but on harmonizing data, on enabling self-service, on connected data with graph technologies as well, and tying in both the relational version and the graph version in our database, in our environment. So I think, like any good architecture slide, you need to have one. And we focused on an open modular architecture. We can leverage what Databricks provides. We can also switch out technologies as it's available. And I know everyone has a different version of these. This is ours. But I think the most important aspect to this is, what are you optimizing for? What do you care about? Do you care about standardization? Do you care about best of breed? Do you care about flexibility? And I think for us, we found we cared about the following. We cared about having a data center of gravity. So once you had enough data in the same platform, then you had more and more people who would volunteer to bring in the data and add to it because what they already needed was there. And you had internal software products that would continue to build on top of your data lake architecture because what they wanted was already there. So you had a synergistic effect of each new product that was starting to develop on it. That led to simpler handoffs because the challenge is really when you switch across tools or when you switch across personas and you do that handoff, that's where you end up with confusion, complexity, friction of experience. And so then we doubled down on skill set specialization. We wanted to be experts in one tool versus proficient in 5. So we're definitely not 100% Lakehouse yet. There's definitely ways to go, but we're moving in that direction. And so where is it that we want to get to that would lead to more of 100% Lakehouse? I think simplification and performance. So we just heard about the SQL talk. I'm excited to learn more about it because that's an area that's been causing us to replicate data off the Databricks environment for sub 2-second queries where you need to have interactive experience. So excited to try that out. The usability and governance, so lineage, discoverability, fine-grained access control. If you unblind a clinical trial, you're basically in a lot of trouble. So more and more governance, more and more controls. And then in the long run, I think we're interested in how do we unlock other personas, not just the Databricks personas, but users who can't write SQL, users who need to explore data, developers who aren't actually really developers, like we heard about analytic engineer from DBT, things similar to that. So if this sounds interesting to you, we're hiring. We have 200 plus remote positions. We're in the business of trying to save lives. There's also 2 other talks on Amgen that go much more in depth than what I was able to do, one on our commercial business and one on a deep dive within our data platforms and other platforms around it. And with that, I'd like to say thank you, appreciate the time, and enjoy the conference.